In this video, I'm going to show you how to create the Mega Man X-like Sega Genesis you see on screen with Claude, some pre-game assets from itch.io, and a little bit of elbow grease. In my last video, I walked you through how to create a Claude skill for use with the SGDK Dev Kit. We will need that for use in this tutorial, and you can find a copy of the Claude skill we created in that video on my GitHub linked below. In the video, I use a slightly modified version of that skill that I've tailored for my personal use. If you're interested in that, you can find it on my Patreon, but it is entirely unnecessary. You'll also need a copy of the SGDK Dev Kit in the working folder you're building in. A couple of key points before we go much further. We are making a Sega Genesis game for an actual Sega Genesis. That means the real-life limitations of the Sega Genesis will matter a lot. Claude will help you with this, but it helps a lot if you keep this in mind while you're working on your game. If all you're wanting to do is create a game you could play on your computer, there's lots of other guides out there for making games with modern engines that do not have such limitations. I will touch on quite a few of the key limitations in this video, but it is by no means exhaustive. First thing to do before you do anything is make sure you have a clear idea on what your game design is going to be and that it's conscious of the hardware limitations. Personally, I use Google Gemini to help scaffold general game designs, but feel free to use any AI model you like. One thing to note, we really want to use the game design as a guide for prompting Claude. If you give Claude the entire game design, it will use too much of your context window and it will fail to write any code. That's because Claude will attempt to read the entire game design and not focus on the tasks that you need it to do in an orderly fashion. Once you have that, it's time to start building. And please, before we get started, if this video helps you or you find it interesting, drop a comment, leave a like, and subscribe. And smash that bell for alerts. Every couple of weeks, I'll be developing different games for different retro consoles based on your guys' feedback. Now let's get into level design. Since we're making a Mega Man-like game, I grabbed the free Reploid pack from itch.io, link for which is in the game description, which has a nice tile set for making Mega Man-like levels. A quick note on one of the key Genesis limitations and how to work around it. You can't simply ask AI to make levels for you and expect them to work on 30-year-old hardware. There are just too many limiting factors, and you will spend much more time massaging the results. All you modern gamers out there complaining about having 8 GB of VRAM on your graphics cards can politely take a seat. The Genesis has a whopping 64 kilobytes of VRAM. That is less than 0.01% of the VRAM of a modern budget quote-unquote graphics card. What this means is the mad scientists in the 90s had to come up with some really clever tricks to make games like Sonic 2 look the way they did. The trick in this case is that tiles, or otherwise 8 pixel by 8 pixel images, can be repeated many times on the screen without requiring additional VRAM. This is similar for sprites, but more on that later. What I've done here is ask Claude to use the existing tile set to make levels instead. I asked Claude to make me a procedurally generated Mega Man level using the tile set. It took a couple of prompts to clarify where which tile is, but once we got it dialed in, it worked really well. I asked Claude to create a Python script so we can run it as we need to. We then needed to do something similar for the background. Technically, the level is also a background, but this is how we achieve the awesome parallax scrolling effect that makes games from this era appear 3D. A quick note on parallax scrolling. The Sonic example on the SGDK source has a very good example of how to get the 3D look with your backgrounds, which is referred to as parallax scrolling. I refer to this example regularly, and I tell Claude to refer to it regularly when developing side-scrolling games, as it really adds so much character to your game. The level generator script I finally settled on is uploaded in my GitHub, which Claude can help you customize to your heart's content with different tile sets should you so choose. Remember, it's very important that your levels are made with tiles or repeating sets of pixels. Each new 8x8 pixel grid is another tile used in your VRAM. One final thing to mention on levels, especially for platformers, is it will need a collision map, which is basically a glorified Excel spreadsheet that says which pixels are solid and which ones are not. Claude can help you with this with ease. You can also use something like Tiled, which is a free software for making maps with tiles yourself. With the level and the background out of the way, it's time to move on to our main character, enemies, and boss. We're only making one level in this tutorial, but would be easily replicated with different sprites, different enemies, different tile sets or backgrounds, etc. This step is fairly straightforward, but there are a couple of key considerations. One is we are limited to 16 colors per palette and 4 palettes on screen at any time, which means there are only 64 total colors we can use. So typically, I recommend, and Claude will recommend, one palette for your backgrounds, one palette for your character, one palette for your enemies and bosses, with the fourth palette being your flex palette for anything else you might need, like your UI, etc. Each level can have its own palette, so don't feel like you're locked into a specific color design for every level. Probably the most important thing to understand outside of palettes with sprites is that for player characters, the entire sprite sheet does not have to be loaded into VRAM. It can be loaded on player input, which means you can use much more complex animations in your sprite sheets for player characters. For NPCs, however, the entire sprite sheet must be loaded into VRAM for the game logic to use, so you must be mindful of those sprite sizes. Ask Claude for help with this at this step. Ask Claude, please look at the sprites in my folder and estimate Genesis VRAM usage. Suggest edits, resizes, etc. You'll also want to ask Claude to analyze with Python the dominant colors in your sprite sheets to determine adequate color palettes. As for the actual sprite sheets themselves, in this video I use some absolutely beautiful free assets from itch.io. They're on the screen now and the links for them are below. This saves so much time versus creating them with AI. You absolutely can create sprite sheets with AI, and there are a lot of tutorials out there for that. I just find that it takes a lot of time and tokens to actually make them look right. You're better off using something from somewhere like itch.io. In a lot of cases, even if you buy them, it's cheaper than what it would cost to create them with AI for what it's worth. And believe me, the irony is not lost on me that we're using AI to make games, but whenever you can support original content creators or developers, I strongly suggest you do. In our case, we had sprites in a variety of formats, so I asked Claude to help with the scaling, cropping, quantizing, which is the process of converting to the correct palettes, and then creating the sprite sheets in the format the SGDK wants. Claude handles this step very well, as it primarily uses Python, and if it doesn't, stop it and tell it to use Python, and an extension called Pillow to process images very efficiently and effectively. All of these things I placed in easy to access folders for Claude. The more specific you are, the better. The last final bit before we're ready to prompt Claude is to get some sound effects and some music. I created 2 Claude skills for help with this. One is to compose music with the Genesis synthesizer outright, and another to convert MIDI music to the VGM format SGDK expects for the Genesis synth. I've had a ton of fun with this from a chiptune perspective, and maybe I'll make a video of that in the future, but for purposes of this video, I grabbed some MIDIs from the frankly awesome HTML era website on screen and linked below and converted them to VGM. These Claude skills are available on my GitHub. For sound effects, I grabbed the free sound effect pack from itch.io and pulled out what I wanted. Now, this is unbelievably important step for sound effects. The Genesis compiler has the ability to downsample audio in high bitrate formats, but it is awful. Use the tool in the link below, SOX, for converting waves for sound effects on the Genesis. Ask Claude for help with converting your WAV files with SOX. It will provide to you the correct command prompt to convert any WAV file into the format that the Genesis can play. Once we have all these files in an easy to access folder, it's time to prompt Claude. This is the part where I would strongly suggest you take your time being very specific and giving Claude very specific instructions about what it needs to do, and start by telling it to scaffold the game rather than make the game. The key consideration here is that we don't want Claude to try to build everything in one prompt. It will fail. It will use all your tokens and you will run out of usage and you'll be very angry. In our case here on the screen, you'll see my prompt. We are making a Mega Man X Souls-like where your main character is like Zero from Mega Man X. Setting the stage for Claude is important. The first part of a prompt guides Claude how to do steps in the rest of the prompt, what it's doing, why it's doing it, etc. SGDK is located in C SGDK. This is helpful to point out in case it's somewhere else, because the skill will assume that's where it's pasted, and it could be annoying trying to compile if Claude doesn't know where the compiler is, and it will waste a lot of tokens trying to find where the compiler is. Punishing one-hit death gameplay. This is a key consideration for the game I'm trying to make. Can wall jump like Mega Man to ascend. This is for the Mega Man style wall jumping. No HUD. I put this because Claude will usually expect you need a HUD in your game, and it can take away resources and add additional bugs if it isn't needed. Left to run, A to attack, A hold to charge, B to jump, C to charge. I added some specifics to this game, aka jump height and width, which is derived from the level generator that we created, but you might want to customize this for your purpose. Background will be parallax scrolling. See Sonic example in SGDK sample game folder. Has the specifications that match our exact background provided in the folder, same resolution, etc. This is one of the important pieces of the prompt because it is a little bit complicated for the camera logic, and it's difficult for Claude to go back and deal with it. So it's definitely one of the things if you're gonna be doing a parallax scrolling game, that you're giving it that context up front, so it can build the camera with that in mind. The next part of the prompt deals with where the background files are located. I've defined where the music is located. I've told it where the sound effects are, and that to tell Claude to set up placeholders for the missing ones. And then finally, I tell Claude that sprites will require a significant amount of processing, so let's do that once we have the core gameplay scaffolded. That means that Claude won't try to make all the sprites and characters as part of this initial prompt, and we'll fill that in the next part of this video. So after that's done, sit back, grab a beer, do whatever you need to do while Claude does what it does and sets up the main source file. On screen, you'll see, since I asked Claude to help with the sprite sheet generation, you can see I'm guiding the Claude with specific instructions for what our sprite sheets look like, who are our characters, you know, what are their animations like, etc. Once that's done, after not that long, we have a functioning game. In my case, we had some bugs that had to iron out, and frankly, we still do have quite a few bugs to work out. But the biggest issue that I encountered was for the parallax scrolling, which it turns out that the issue was related to the Python script that was making the image file for the background was not making the black the index 0 for transparency. That's actually fixed in the Python script that's uploaded in the GitHub. So theoretically, you won't have that problem if you use my level generator. And so yeah, so that's it. If this video was helpful to you and you are gonna go make a game, then please leave a comment, like, and subscribe. Thanks. Take care.